Hi everyone, thank you so much for joining us today. Welcome to our February webinar. This month we're talking about the new and improved GeoWAN sensor range. So as always, before I begin, just going to run through a few housekeeping notes. So we'll be having a short Q&A session at the end of the webinar, so please feel free to type your questions into the question box as the webinar goes along, and we'll answer them at the end. Just to let you know that the webinar will be recorded and sent out to everyone who's registered afterwards. So I'd like to now introduce you to our speaker today, Dom Quiche. Dom has worked in the instrumentation and monitoring sector for 15 years and has been involved in some of the UK's largest infrastructure schemes. He has a wealth of civil engineering and rail knowledge. Dom's expertise has been pivotal in championing our award-winning intelligent monitoring solution, Infraguard, as well as the successful launch of the digital interface node and Senceive IO. So, over to you, Dom.
Thank you, Emma. Good afternoon, everybody. Thanks for coming to my webinar on our latest launch, which is our new product range. The aim of the talk is obviously to introduce the new product range, but also discuss and hopefully explain the importance of this launch and its supporting products. I'll aim to take you through exactly what we're launching, the meaning behind it, and the importance behind that product line, and finish off with some examples. As Emma said, if you pop some questions into the chat column, we'll hopefully have enough time at the end if I haven't answered them already through the course of the webinar. It should only be about 20 minutes, and so thank you very much for taking the time out of your day. Okay, so hopefully most of you are familiar with Senceive and our product lines. We offer two major wireless platforms, and underneath those we have a range of hardware products that sit under both that flat mesh and GeoWAN. Mesh is our proprietary system. It's where we have our Infraguard camera systems, and they're linked with a lot of our major applications. LoRaWAN has predominantly been used as a supplementary system and uses for our long-range deployments. This is what we market as GeoWAN. We also introduced, as Anna said in the intro there, Senceive IO as our data management software. That was new to Senceive in the last 18 months. And then we have our data visualization platform in Web Monitor, which is where you can see all the data, create plots, create alarms, and so forth. So this specific project and subsequent launch was about re-evaluating our GeoWAN, our offer, and the market base that we're going forward, and how we introduce that to the market. So our GeoWAN product line utilizes LoRa technology and is Senceive's version of the LoRaWAN protocol. It allows wireless communication over long distances by sending very small packet sizes. LoRaWAN in general is a relatively open source protocol and allows the user to utilize the technology that's available to transfer those data packets. But it does have restrictions and rules around which users have to follow. We first launched this tech in 2018 in order to cater for projects where there was no packet size data sets. We were sampling at low frequency, and we had relatively low risk projects that required monitoring. We decided that we needed to take a closer look at how we support this product line, how we position it, and what value we can add to this process. Our focus has always been to bring closer integration with our management platform and Senceive IO. We want to make the route easier for clients to purchase and set up their products, as well as an overall simpler experience to coincide with the simple and effortless technology. As some of you have seen, we launched Senceive IO last year, and it was the first step in providing clients with that full access, management and integration into their systems. So this project, specifically GeoWAN 2, was about revamping the hardware that sits on that wireless platform to match that strategy and build on that control for the client base. So what we did, we set about making some key updates to the system. These include integrating all of the tools and all of the processes into our management platform so that they weren't scattered around different parts. So the reliance wasn't still on Senceive customer support team to do all of the remote support and gave that control to the users. But ultimately, it was about the new product range that sits on that wireless platform, where we created a new lightweight form factor that allows easy installation, as well as having a separate battery compartment for easy access, an upgraded PCBA board, which has a long life resiliency and a robustness to it, as well as a new highly accurate temperature sensor for compensation. And one of the big changes was an internal antenna, as opposed to our external ones, and we haven't compromised on range to achieve this, and I'll talk about that in a few slides' time. So these are the products that now sit on our GeoWAN network, which you'll hear us refer to as GeoWAN 2. We still have GeoWAN 1 legacy products available, and we'll gradually phase them out over time. But these are the 6 new additions to that GeoWAN carrier. We have our tilt meter and an optical displacement sensors, as well as some of the key interface nodes from our wider range. And we also have our digital interface node, which I've not included on this slide. And we released that last year, and there was a GeoWAN version, so a version of that digital interface node that uses the LoRaWAN protocol. So as well as the nodes themselves, we've designed new bracketry to go with each of these to ensure that they can be mounted and fixed to the appropriate material or the appropriate asset. And it ranges, from our swivel mounts to right angle brackets to a wide range of different precision mounts for the optical displacement sensor, if focusing the laser is vital. And where the bracketry might be backwards compatible with our existing, it's no problem to do so. So, for example, the swivel mount can be retrofit to a horizontal plate and so forth. So I'm just going to run through some key features of the range that sits on GeoWAN. And a big change is the placement of the antenna. We've moved it inside the node, so it sits inside the lid. You see it on a picture on the next page. And so when you add that antenna and the protector that we used to have to put on the old GeoWAN, compared to the new form factor, it's actually a little bit smaller in terms of total mass. And not only to give it more protection from the antenna breaking off, we've also removed the ability for water ingress that can happen when it gets through the connector part if it gets damaged or kicked. We've still maintained an excellent range. We've achieved these ranges in real-world environments. We don't just make these up or achieve them once and stick them down on a table. We do go out and test these at our test facilities and in the real world. And we test based on what we can regularly sample at, not just what's the maximum. So when we put these numbers down, like 12 kilometers or 1 kilometer on a track bed, it's not the maximum range that you can get between a GeoWAN node and a gateway. It's what you can reliably pull data from when you install it at that point. And as I said, we carried out extensive testing at our facility to understand the things like the RSSI strength, the different ranges, the different placement of nodes and how that affects the range, the different placement of the gateways and how that affects the range that you might achieve. and different types of furniture that might impact the signal and how it travels through. And we do this to be able to offer a much stricter guidance and a much more concise guidance on what you can expect. But wireless is a bit of a dark art, especially when it comes to the longer range systems, and there's lots of things that can affect it. We also put it next to our existing GeoWAN, so you can see there in the picture one of our old nodes with the antenna cap next to one of our newer nodes. And the results were extremely positive. This is a plot where we installed a gateway at our base site, and we installed sets of nodes 200 meters, 400 meters, 600 meters, 800 meters, up to 1 kilometer on track. So this was at ground level, away, and all those distances are away from the gateway. And the objective here was to set it out in the worst case scenario. So gravity has a big impact on wireless. The closer to the ground you have, the shorter the distance generally wireless travels, because gravity is pulling it down into the earth. And so we set up this test as amongst others, where we ran the sensors at 15-minute intervals, and this plot particularly represents over a month's worth of data. As you can see, we're averaging between 90 and 100% of the readings, all the way up to 1 kilometer away from the gateway. In fact, the main loss was when someone actually put a container in front of the gateway as we were testing, and we started to lose a few sensors. It wasn't even the distance that even got us down to 90%. We could read further than this. We actually managed to get track readings up to about 2.5 to 2.7 kilometers away from the gateway, but we did start to see packet loss. Sometimes the signal would get through, sometimes it didn't. There are ways of getting around that and increasing the sample rate to achieve what you need. But like I said, we want to be realistic and talk about what people can expect in a real world environment. Another key development is the separation of the battery compartment. This allows quick and safe access to the battery holder without jeopardizing the inner workings of the node or the sensor. The battery itself can be supplied by us still, by Senceive, or it can be supplied by another source locally in the country, or directly from our vendors. This is a very important change for Senceive and piggybacks off of our digital node, where we are trying to give more control and management into our clients' hands to allow them to start, stop, change batteries whenever they want. And it also reduces the impact or potential impact of dangerous goods shipping. Some of you might be aware, if you bought some of our goods, our batteries are installed within the node, which means you have to pay a higher rate to ship them, to make sure they're safe. Some carriers won't even ship them, so it does add cost on. If you can source the batteries local within your country and not cross borders, it does remove that cost and allows you to buy and send back any nodes in a much easier fashion. So the way in which one of the last key features that I sort of want to talk about is how we're trying to make our nodes, we're calling gateway agnostic. So many of you will know, but the way in which LoRa operates means that every sensor emits a signal or data package, and if there is a gateway within range, it will collect that package and pass it back to its network server. And from there, a user might draw down their information, decrypt the information they need, and display it on their data visualization platform. But what it ultimately means is every gateway can pick up a signal from any node. We supply our own gateways. We do maximize the gateways the gateways performance that we do supply, but ultimately we buy these off the shelf and export them around the world. So we don't add a whole lot of value to that. So when we think that the gateway really does just simply act as a gateway to the network server where the data is pulled from, so we don't see a real value add from our perspective. So we've tried to make our nodes as agnostic as possible. So you would have seen probably a couple of months back, us release some information on how a user could go and purchase their own gateway. They can load something called LoRa Basics on it and point it at the right network server, and the nodes will be pulled into our Senceive IO backend. So you don't even now have to buy our own gateways if you want to use our LoRa-based nodes. We're also working towards where we can interact with public network servers. And this is a big drive for some countries, some asset owners, and some smart cities, where they create a LoRa network. You walk along, you place your node within that LoRa network, and a bit like I was explaining earlier, the gateways pick up that data and pass it back to their network server, and then we connect on the back end, and effectively that's the work. It's the integration on the back end to pull that data set into our data management platform. So why is this development, why has it been so important, and why does it matter? You know, as mentioned, a large part of was about making sure that we set this product line off on the right strategy as an offering. We needed to make sure we provided an alternative option to our premium product line of flat mesh. The launch is closely linked with our data management system, which then gives that added incentive to clients to take complete control. And you know, when flat mesh isn't required, and LoRa by its nature, it limits what you can do with in-field wireless transmission due to its packet size and its regulation. So we decided to keep it simple. We wanted to launch this product in line and at a cost that reflects the easy nature of the system. You know, we're an international business, and we don't want to make it hard for people to buy our products. Where we have to ship batteries installed means that we have to carry that dangerous goods label. And it creates headaches sometimes for clients if they want to get equipment quickly or cheaply. The batteries now can easily be installed with a simple D-cell battery that we have the spec for, and we can issue, and you can source them from wherever you want without having to go through us if you would like. And finally, you know, just again on that, we wanted the range, or this particular range, we wanted to allow the users to enjoy that full control with minimal support from ourselves. The point-to-point system offers that and goes hand in hand with the lower support fees and the tooling that's required. So the hardware is the front end sort of illustration of this project. There's been a lot of stuff that's gone around in the background to achieve this. So I just want to finish on a few case studies to sort of echo the points of that I've hopefully been trying to make about its value and its importance. This is a recent project we worked on in Kazakhstan. Now, this was installed with our original GeoWAN nodes you'll see from the pictures there, but it represents the value of having a simple low-cost system that ticks away and measures for trends and patterns over a long period of time. The nodes were picked up by a single gateway that's covering a large area, 3 kilometers. The project was together with UNESCO, who were aiming to protect a vital number of buildings that are along the old Silk Road in the Middle East, and the nodes were installed to pick up changes in cracks and rotations on extremely old buildings, spectacular buildings at that. Another great example of GeoWAN's usage was out in Gabon, where we installed a number of nodes to measure a bridge and slope failure in very remote areas, like so remote that there was actually no cellular signal, and we needed SATCOMs to provide the connection back. Due to the small packet size, and it really suited GeoWAN, and because our sensors were agnostic, and as I was talking to you about the gateways, we were able to integrate them into a LoRa SATCOMs gateway, not something that we produced, with little or no fuss, and meant that the system could be deployed quickly, and was registering data and sending that back to Senceive GeoWAN Web Monitor through the SATCOM system. Finally, this was an example of an integration where we installed a number of sensors to look at the behavior of the foundation of a refinery tank in the US. the nodes were installed around 800 meters away from the gateway, and the gateway needed to be connected. The main aim of this product, the main restriction or challenge of this project, was that the gateway itself had to be connected into the local system. So you couldn't rely on things like cellular; it had to connect straight into the network. And so it showed the value of the range, because the gateway then had to be effectively where the head office was within this site, and had to see nodes that were 800 meters away. But it also showed the value of Senceive IO and Senceive IO Local, which could be installed on the system and then pick up the data through the network. So as I said, this system doesn't rely on cellular or SATCOMs, and it's talking directly in a closed system on site, which is brilliant. Excellent. So thank you very much for your attention this afternoon, and hopefully I've given you a quick overview of the product range and the launch. Hopefully I've given you the understanding of not just what GeoWAN 2.0 is, but why we did it, and setting it apart from flat mesh is important to us. It's a hugely malleable system, and it's designed to really suit those who want to take control and integrate into their wider systems. Welcome. I suppose any questions that we might have at this stage, Emma?
Yeah, we've got a couple, so let's run through those. The first one is, will the antenna-less design be applied to the flat mesh nodes, such as the VW node, etc.?
Yeah, we'll wait to see the success of this, but we are looking at what we can understand and garnish from this, and whether we apply it to our flat mesh system. I think the ability to protect the antenna, and it usually is when we look at our RMA systems, a lot of the terms are founded upon when there's been damage to the antennas. Obviously our nano range doesn't have that, but the interface range still uses the IXH version of flat mesh. And so yeah, we are thinking about what we might do with the future on that to remove the dependency on the external antenna. And one thing I forgot to say throughout this presentation is, if there is a need to use an external antenna because of where you want to put the node, we do have a special lid that allows you to extend the antenna away from the GeoWAN node as well. So if you need it for those cases, we can still do that.
Okay, let's see. Another question is, someone's asked, so there doesn't seem to be much development on the wireless element itself.
Yeah, that's correct. I mean, LoRaWAN is an open protocol, but it's a restricted one. You're limited to the bandwidth that you have. So as a standalone wireless system, there isn't too much you can do and play with to add your value add. So we wanted to focus on supporting the elements that make it easier for the client. So making it easier to buy, making it simple to set up, simple to manage. It's an extremely useful and valid method in the world of monitoring when it's used the right way, and we want to make it as easy for people as possible.
Okay. Another one is the stated max range a radius or a diameter?
Good question. It's a radius. It's definitely a radius, but I will always caveat, and regardless whether we're talking about LoRa mesh or Wi-Fi, whatever frequencies we're talking about, there's always things that can impact the wireless signal. So yes, it is a radius around that gateway. It should pick up in both directions or any direction outside of it. But depending on how you install that gateway, where you install it, what height, whether it's got big concrete building one side and an open plain the other side, might mean that you don't always achieve that radius.
Thank you. Another question, if using the tilts with a 3D party gateway, will the I/O be a requirement with a connected license fee, or could you push data directly to any visualization tool of choice?
Yeah, good question. So that it will always need to go through Senceive IO, because that's where the decryption comes. At the moment, the way that gateways work, they send the data back to a network server. we would then decrypt it from within Senceive IO and send it, and then it would be pulled out to a third-party platform. At the moment, there isn't any intention to be able to pull straight from that network server, because Senceive IO basically does the interpretation for you, and then allows you to pull it from there.
Okay. Another one. So does the price point reflect the simplicity of how you're positioning?
Yeah, so in answer to that, in short, yes. We believe we made the price point very competitive to match its standing within the field of monitoring. Please contact your BD person or myself directly for exact pricing, because it changes a little bit from geography. But on average, we're looking at 20 to 30% less than our flat mesh range. And we've tried to be reasonable about what it can achieve versus that flat mesh range. So hopefully it's a lot more competitive within the market.
Okay. Another one is, can the antenna really achieve 12 kilometers of range?
Well, yes. Again, yes is the short answer. But I'll always caveat it with wireless is that dark art. And some of the ranges we achieved through testing have even surprised us of how well they've performed. But these are examples, and caution should always be the foundation to any wireless system. And using case studies is your best foot forward to see how it's performed on other sites to get the best example of how it's going to perform on yours. Anything can affect the node from furniture in the way, how high the gateway is. But yes, in short, if at the right height and line of sight is available, which in all honesty, there's not many locations where 12 kilometers line of sight from point to point is available, but it can achieve that, yes.
Okay, got a few more here. Let me just go through them. Someone's asked, are you able to tell me what battery make model you use so we can solve for tame?
Yes, we can. On our data sheets for this product, if you go onto our website, you'll see the exact make model that we use. We're certainly not precious about that. You can go and source your own. We could even give you contact details of where we get it from. You can go source that as well.
Cool. And the last question, in regards to the node casing, has this been UV tested for extreme sunlight conditions over time?
I'd be lying if I said over time. We've done UV testing, we've done all of the relevant certifications, and we put it through very strenuous testing. No, we haven't put it in over time. We've had it outside for 6 to 9 months. So we're very confident about how it can perform. But no, we exposed it in labs to extreme testing, and we can speed that process up. But I suppose it depends on people's version of over time. The maker and the material has been qualified to be able to exist and work within that. So it's not something we're particularly worried about.
Okay, let's have one last look. I think we have covered all of the questions. Yep. Oh, okay. So I think that is all of the questions, but obviously if you do have any more, please feel free to email us at info@senceive.com and we'll have someone get back to you. We'll also be announcing our March webinar soon, so please keep an eye out for that. I just want to say thank you to Dom and everyone who joined us today, and I hope you have a great rest of your day. Thank you.
Thank you very much.